Bismillahirrahmanirrahim. Bismillahirrahmanirrahim. Dear students of class 11th, our topic for today's lesson is Lami's theorem and concurrent forces. Lami's theorem, it states that if three forces acting on a particle keep it in equilibrium, then each force is proportional to the sine of the angle between the other two. So three forces are acting on a particle, they keep it in equilibrium. So particle in equilibrium, then they are relation that the sine of angle, each force, that force is proportional to sine of angle between the other two. So if you see, if we have force F1, F2 and F3, then the angle between F1 and F2 is gamma, and between F2 and F3 is alpha, and F2 and F1 it is beta. So force F1, the angle between other two is alpha. For F2, force between other two is beta, and for other three, for F1 and F2, the angle between them is gamma. So it stated that sine of F1 by sine alpha is equal to F2 by sine beta is equal to sine F3 by sine gamma. Now let us represent a particle at a point O is in equilibrium under three forces F1, F2 and F3. Let us represent these forces by three sides of a triangle ABC. So F1 is directed along AB, and force F2 is directed along BC, and force F3 is directed along CA. So that is a triangle, and so they are taken in same order. AB is BC and CA. So when the three sides of a triangle, this is also a condition for the equilibrium of the net force on the particle is 0. The angle between F1 and F2 is gamma, and BC and CA, that is F2 and F3 is alpha, and between F3 and F1, that is CA and AB is beta. So now exterior angle is gamma, so interior angle ABC, interior angle ABC is pi minus gamma. Similarly, at point C, angle BCA, that is the interior angle of the triangle ABC, is equal to pi minus alpha, and similarly angle A, that is CAB, is equal to pi minus beta. So as from the trigonometry, we know the law of sinus, that is in a triangle, side AB and divided by the sine of the angle of the opposite angle, that angle C. So AB divided by sine C is equal to BC divided by sine of A, and CA divided by sine of B. So AB is F1 and angle C is sine of pi minus alpha is equal to F2 sine of B alpha pi minus beta and F minus sine. Now we need the sine of 180 minus A is sine, again sine, it is in the second contour, and sine is positive in second contour, so we get F1 by sine alpha is equal to F2 by sine beta is equal to F3 by sine gamma. So that way we prove the Lami's theorem. Forcing concurrent forces. when force is acting on a body at a common point, they are called concurrent forces. They are called concurrent forces. If you see the figure, we have a point where force F1, F2, and 3 they are acting upwards. So a body is said to be in equilibrium if the vector sum of all the forces acting on it is 0. We can see by find the resultant of F1 and F2 by particle law of vectors. So F1, F1, we will complete the parallelogram. Then the diagonal OC will give the resultant of F1 and F2. So if the body is in equilibrium, then F3 must be equal to opposite of resultant of F1 and F2. So F3 into minus F1, F2, or F1 plus F2 plus F3 is 0. That is, three concurrent forces will be equilibrium if the vector sum of the forces is 0. If the total or resultant of 2 is equal and opposite to the third. Resultant of two forces is equal and opposite to the 4. So we end here the part of this force dynamics of. We will now study the another type of force, that is friction, and laws of friction there. Then we will have to prove, that is our practical part, do our practical manual, that is the proving the laws of friction, then reducing and converting the reducing the friction, and in sometimes we need to increase the friction, then to solve the problems when a body moves and we take in consideration the friction. Till now we were ignoring the friction, we were only concerned with the that is only the force acting on the bodies. Thank you.